Hi everyone. Earlier this year, I had the real pleasure of chairing a panel discussion at the APE conference in Berlin about the tensions between quantity and quality in scholarly publishing. At the start of that session, I presented some slides to show how article volumes have grown over the past decade. The video that you're watching now takes that work and expands upon it. I've done a deep dive into some of the core trends behind the increase in article volumes using Dimensions, a bibliometrics tool from Digital Science. I should make it clear from the outset that this video has been sponsored by Dimensions. I wouldn't have been able to spend so much time on this project without their kind support. However, I've had full editorial control over the analyses and the conclusions that I've drawn. I'd also like to thank Eric Shares, who's a librarian at Iowa State University, for providing feedback on an earlier version of these slides. Of course, any remaining errors are my own. So, this presentation is split into two parts. In the first part of the video, I'll talk you through some of the underlying causes for the growth in article volumes over the past decade. In the second part of the video, I'll show you how I use Dimensions to generate the data that I'm about to share with you. Okay, so let's dive into the data. And what I'm going to show you today is based on research articles that were published over the last 25 years, so between 2020 and 2024. Now, you'll have seen a version of this graph many times before, I suspect. So we've plotted here the number of research articles on the y-axis, so going up to just over 4 million versus time. So between the year 2000 and the year 2024. And you can see that there's a steady increase over time. But it was particularly steep between the period 2019, 2020 and 2021, which of course coincided with the pandemic. So during that period, obviously there were additional articles around COVID that wouldn't have been published otherwise. But of course, academics were also, a lot of them were at home writing research papers using data that they already had. So that could be part of the increase. But on top of that, there's also the underlying factors that have been in play for quite a long time, like the rise of China or potentially the increase in open access business models, and also bad actors in the form of paper mills. So there's lots of different reasons why this graph could look the way it does. And what I'm trying to do here is just talk you through the different factors that could be at play so we can try and understand what's happened over this period. So this graph shows the same data set as the previous graph, but what we're looking at here is the year-on-year increase. So we can see that 2018, 2019, 2020, 2021 were all above average when it comes to a year-on-year increase. And then that dropped down in 2022, 23, and also 24. Now, we need to be really careful about how we interpret the 2024 data, because when I ran this report, which was on February the 6th, it's quite likely that there are some articles that were published in Q4 of 2024, probably from smaller publishers that haven't been indexed yet. So we need to be careful about how we interpret the data. I mean, in many ways, it'd be better to wait until June or September and redo this analysis, but I wanted to try and get an early view to you of what might have happened last year. Now, Eric Shares has done a nice analysis using the publication data of his university and when they appear in various bibliometrics databases. Dimensions, according to that piece of work, is actually quicker than some of the others. So I'm fairly confident that we've got most of the data in here. It's probably 95% of the data are probably captured, but we don't know for sure. And there's other elements of the 2024 analysis that we need to be careful about, and we'll talk about that as we go through. But this graph is the year-on-year change. Let's, as we go through this presentation, just be a little bit careful about how we interpret the 2024 numbers. Okay, so let's start with COVID. This is obviously one reason why the graph should have been so steep during that period. And so what I've done here is a really simple search in Dimensions. I've just searched for the word COVID to see how many papers were published in each calendar year. And you can see those purple bars there the additional papers that were published related to COVID. And there's about 1.7 million of them that have been published to date related to COVID. And over the past 4 years, around 10% of all articles have had the word COVID in it. So it's obviously a significant factor. The increase that we've seen is related to the pandemic. And on top of that, of course, as I said before, some academics would have been working from home and writing up some additional papers unrelated to COVID that may have caused this increase too. But one of the other core trends over the past decade is the rise of China. So what I've done here is a search for China to look to see how many research articles have at least one author from China, and another search for research articles that have no authors from China. So that's the not China bar. So these are two mutually exclusive searches. You can add them together to provide a stacked bar graph, as I've done here. So you can see that last year in 2024, at least at the point when I'd run this analysis, 743,000 additional, 743,000 research articles included at least one author from China, which was just over a 16% year-on-year increase. So China continues to grow. And if we compare that with the output in 24 compared to 2023, which is a 3.4% year-on-year increase, again, based on when I ran these data, you can see that China is continuing to grow in influence. This is the same data set, but presented in a normalized fashion, so 100% on the y-axis down to 0%, and you can see that the market share from China is increasing over time. Okay, so now let's move on to open access, which is another reason why we could have seen such a big increase. This graph is a little bit complicated, so let's just take our time talking through it. Again, on the y-axis, we've got number of research articles plotted versus time. But there's 5 different elements to this stacked bar chart. So Dimensions uses a classification system from Unpayable to classify content as either gold, which is articles published in fully open access journals, what Unpayable calls hybrid, which is open access articles published in hybrid journals, green open access, so that's author-accepted manuscript, for example, put into an institutional repository. Bronze, which means that it's free to read, but not with an open access license. So, for example, some journals make their content free after a year, put it in front of the paywall, but it's not proper open access, it's just free to read. So that's classified as bronze. And then closed, the black bars there, are paywalled articles. Now, the Eagle Eye members of you will see the big increase in 2024 for closed. We need to be careful about how we interpret that, and I'll talk about that a little bit in a minute. But what I want to concentrate on at the moment is the gold and the blue bars, this big increase in open access content over time, not necessarily flipping content that would have been subscriptions. You can see that closed and bronze have increased year on year. The red dotted line is not a regression line. It's just me eyeballing it just to show that if you add, green, bronze, and closed together, it's a pretty linear growth between 2000 and 2024. A lot of the extra growth actually has been gold and hybrid. Now, of course, many of those papers would have been COVID related or from China, and there's lots of ways that these different factors are intermingling. But the growth in open access has to be, at least in part, in my opinion, responsible for the growth that we've seen in the curve in article output. So this graph is, again, the same data set but normalized. And you can see that gold and hybrid last year both seem to have shrunk compared to the previous year, with the caveat that we've already mentioned about 2024. We need to understand what's happening with closed and bronze and green. But of course, if you have an open access article, it can't become more restrictive. So in other words, you can't make an open access article closed over time, but you can make a closed article open access over time. So, we'll have to wait and see exactly how this graph plays out. But there seems to be a trend there of maybe a shift away from gold and hybrid, but we'll have to see how it plays out as the year goes through. So this graph is diving deep into just the gold open access papers. So in other words, research articles published in fully open access journals like PLOS One or Scientific Reports or that kind of journal. And what I've done here is plotted the 5 biggest publishers of fully OA journals, so Wiley, Frontiers, Elsevier, Springer Nature, and MDPI. So they have their output individually showcased in this graph, and then I've lumped all other publishers together. So you can get a sense that what MDPI, for example, had a lot of those papers in recent years. Elsevier is growing, Springer Nature's up there. But perhaps an easier way of understanding what's what is by looking at this graph, which again is normalized. And you can see that over time that Elsevier has grown, MDPI has clearly grown. Springer Nature's market share actually, although they're growing in absolute terms, very strongly, their market share, according to this analysis, has shrunk. Remember back in 2000, it was relatively small numbers of papers. BMC would have been part of that in terms of the acquisition. So yeah, it's difficult to entirely interpret this, but it does look as though other publishers, if you want to lump all those together, their market share seems to be shrinking over time of articles published in fully OA gold journals. So which publishers hosted the most gold research articles in 2024? So all I've done here is compare 2024 with 2023 for the publishers here. You can see MDPI, Springer Nature, Elsevier, Frontiers, Wiley, etc. And the absolute change, so that's the delta number, and also the percent change, so the percent difference between 2024 and 2023. And you can see clearly, as we know, MDPI and Frontiers shrunk last year. Some of the other publishers, and particularly the bigger publishers, the Springer Natures, the Elseviers, the Wileys, OUP actually in percentage terms grew a lot. But you can get a sense of who, at least in this top 20 table, grew and shrank in the last calendar year. If we then delve down just to the fully open access publishers, so the PLOSes or the MDPIs or the Frontiers, how did they do? So we've already talked about MDPI and Frontiers shrinking. PLOS increased by 10%. The biggest relative change actually is eLife. You can see there only 961 additional papers in absolute terms, but 56% growth. So yeah, you can get a sense that perhaps fully OA publishers maybe some of them are not growing in the way that perhaps they might compare to the Elsevier's at 30-odd% growth. So Elsevier has published for the first time more gold and hybrid research articles than any other publisher in 2024. So this graph shows gold plus hybrid put together. So we can, you can see there MDPI at the top, peaked in 2022 and then has dropped over time. Elsevier has become the leader last year of gold plus hybrid, Springer Nature a little bit behind. So if you combine the two together, gold and hybrid, then obviously, the big players that have big transformative agreements, that kind of thing for their hybrid journals, they leap ahead in the rankings. This is the same graph again, normalized. You can see that other publishers, when you consider gold plus hybrid together, their share is shrinking over time. It looks as though the big 5 publishers that I've listed here are the ones that have grown over time. Everyone else is seeing their market share shrink. Okay, let's now have a little think about what Dimensions and Unpaywall calls closed access. This is why we need to be a little bit careful of the 2024 data. So, according to this graph, there was a huge increase in closed, but it seems to me that's largely an artifact of when I did the data analysis, when I did the assessment. Because you look at the bottom with the bronze curve. So bronze has suddenly dropped. I can't think of any reason why bronze would have suddenly dropped in 2024. it seems most likely that some closed content will become bronze in the fullness of time. And so these curves, so the closed numbers will drop, the bronze will increase, maybe green will increase too. So we need to be really careful about how we interpret this. But it is possible that closed grew last year, but at this point we don't really know by how much. And then finally we come on to paper mills, which could also have been partly, one of the underlying reasons for the growth in article volumes that we've seen. And of course, we don't really know how many articles are from paper mills, but one analysis from Adam Day from Paper Mill Alarm, he reckons that around 1.5% to 2% of all scientific papers published in 2022 have some resemblance to paper mill articles, which if you do a rough, very rough back of the envelope calculation, 4.2 million research articles published last year. 2% of that is 80,000 paper mill articles published in 2024. So a very big number, a very big problem, but certainly not responsible for all of the growth that we've seen in recent years. Okay, so let's change tack a little bit and use another aspect of dimensions that I find really helpful, which is their filters for subject areas. Let's have a look at which subject areas have grown the most. And what I've done for this analysis is used Dimensions ANZ SRC 2020 scheme. So it has various filters, and I'll show you in the second half of this video how we do this, but various filters for subjects. And one of them is this Australia-New Zealand Standard Research Classification System, which was originally developed in 2008 and was then updated in 2020. So hence ANZ SRC 2020. So all it is it's a way of defining different subject categories. So there's 22 major categories. So for example, engineering, and there's 171 subcategories. So as an example, aerospace engineering. And Dimensions uses the way that the Australia-New Zealand classification scheme was set up. It uses the schema, the definitions, if you like, and applies machine learning to the corpus of content in Dimensions if there's enough text in that article to apply one or more subject categories to it. And in my experience, they're normally pretty good. It's not perfect. It's not as though every article is classified perfectly every time. But when you look at it at a population level, it gives you a pretty good sense of the direction of travel. So let's delve into at first the major categories. So these are the 22 major subject areas. Which of them have grown the most over the last decade? And I've sorted them here by delta. And what I mean by delta is the change between 2024 and 2015. So this is just over a 10-year period, not the 25-year period that we were looking at before. So engineering has increased the most in absolute terms, but I've also got the CAGR, so the compound annual growth rate, which is a way of measuring growth over time. So you can see those subject areas which have grown a lot in absolute terms, but also in percentage terms, in terms of CAGR. It's interesting to be able to see which areas have grown the most. If you're a publisher looking to expand your portfolio, this kind of information can be really, really helpful. So these are the major categories. And on this slide, I've just chosen one of them, engineering, with all of the subcategories within engineering. So you can see, so for example, aerospace engineering has this ANZ code of 4001. So engineering is just 40, and then it's 01, 02, 03, whatever are added onto that subcategories within this classification scheme. And so you can get a sense within engineering which areas have grown and which areas, both in terms of absolute growth, but also in terms of CAGR, which can be really helpful as a publisher if you're trying to understand the landscape that you're working in. Now, you may ask yourself, what across the whole of the research landscape, which of the 190 odd categories is growing the fastest? Well, surprise, surprise, the answer is machine learning, which grew by just over 40,000 papers between 2015 and 2024, and a CAGR of 25%. So, not entirely unsurprising, but machine learning is a growth area. But you can get a sense from this table which areas are particularly growing from a research point of view in terms of their output. Okay, so that's all the data that I wanted to present to you. Let's just do a quick recap of what we've learned. So we can see from Dimensions that there's been a huge increase in research articles from around 900,000 in the year 2000 through to 4.2 million in 2024. So that's a CAGR of about 6.6%. Now, I focused in on that 3-year period during the pandemic, 2019, 2020, 2021. And during that period, the CAGR was just close to 11%. And it was likely due to a combination of different factors. So the COVID articles themselves, academics working from home and writing up old data, the rise of China, the adoption of gold and hybrid open access models, and probably also paper mills. Now, the number of research articles published in fully open access journals, Gold, fell by 1.6% last year compared with 2023, and hybrid fell by 12%, with the caveats about this is still an early view of 2024. These numbers almost certainly will change. But will they change, hugely? We'll have to wait and see. We don't know. Now, closed articles increased by 34% in 2024 compared with 2023. And that number, to my mind, would almost certainly drop. I think that's an overestimate because some closed articles are likely to become bronze over time when subscription articles become free to read. And also it's likely perhaps that some closed articles will become green over time. But 34% is a big number. And we will have to see, wait till June, July, August, when the full database, all the data's in Dimensions, to see whether actually closed did increase last year. I suspect it probably did, but we'll have to wait and see. And then finally, we just did a quick run through of which subject areas are growing the most over the past decade. And we use the ANZ SRC categorization scheme to do that. And there's other schema within Dimensions. So that's all I wanted to show you in the first part of the video. If you are interested in learning how I used Dimensions to create some of these graphs, to do the data analysis, then hang on for the second part and I will try and give you some insights into how to do this kind of thing. But if you want to leave now, that's fine too. And thank you very much for listening. So now we're into the second part of this video, and I'm going to talk you through how I did some of the data analysis using Dimensions that I showed you in part 1. I started off the presentation by showing you this slide, which shows a graph of the number of research articles published over time, all publishers, all article types. Let's start off by showing you how in Dimensions to create a graph like this. So I'm going to move over to Dimensions. This is what you see when you log in. First of all, I'm going to put a filter on for research article and article. So first of all, I do article because I don't want chapters, I don't want proceedings, I definitely don't want preprints, monographs, edited books. So I'm going to limit it to article. And then I'm going to add an additional filter to limit it to research articles because I'm not interested in, for example, conference abstracts, or in this case, in reviews or books. So I'm going to limit to research articles too. So if you go up here, you can see at the top we have article and research article as the two filters. If I now go to the overview, we can see or begin to see that graph appearing in front of us. So I'm just going to change the timelines through to what we had over that 25-year period. And then you see the graph of change over time. Now, the slope isn't the same as what you saw because I plotted it in Excel rather than just doing a screen grab of this. And the axes are slightly different in terms of the way that they're compacted. And the way that I would get data into Excel is I'd go to table here, the table view, and literally just copy. So copy and paste it into Excel. And that gives me the information that I need in a format that I can play around with and create a graph of. So the second thing that I wanted to show you is around how to filter by country. So what I've got here in this graph was the number of research articles over that 25-year time period for China and not China, and this is pretty easy to do. So let's flop over to dimensions. We've got the same filter, articles and research articles. And then we can put a additional filter, location, research organization, country, territory, put that down to China, and then limit to. And now you can see that we've got the data over time here that we can again move to a table, copy and paste it, put it into Excel, create a graph from it. But the other thing we want to do is to look at the data that's not in China. So we'll get rid of this filter. I'm going to go back to location, research organization, country, China, China, and this time go to exclude. And now up here you see we have not China, and I can create a table. So this is everything that every research article that doesn't have at least one author from China. I can copy and paste this, put it into Excel or your spreadsheet of choice, and create a graph from it. So that's how I did that. Relatively straightforward to do. So this graph is using the unpayable classification schema that's present in Dimensions, the gold, hybrid, green, bronze, and closed. And I'll quickly show you how you can put together something similar to that. So let's move over to Dimensions again. So we've got the same filter as before with article and research article. Now I'm going to go down to open access. And you can see closed, all open access, gold, bronze, green, and hybrid. I don't particularly like this all open access moniker that they add up gold, bronze, green, and hybrid. To my mind, that doesn't really help us very much. So what I tend to do is exclude it when I plot graphs. So I'm going to go to timeline here, which is a helpful way of being able to see how things change over time. I'm going to change this back to what we wanted before, which was 2000 through to 2024. And you get the graph. But if you want to, and you can use this if you would like to, as I said, I tend to put things into Excel so I can plot it afterwards. You can get the table, pretty straightforward. Again, copy paste into Excel. So right click, copy into Excel, and there you've got the numbers, and you can play around with them at Excel and create what you want with them. So the open access filter is a really, really helpful filter that I use a lot. I'm sure a lot of Dimensions users use a lot. It's a very, very useful thing to have. So in this graph, we've added an additional filter. So we've filtered for fully open access journals, gold journals, and then we've looked to see which publishers, but specifically these 5 publishers that I've chosen, what's the volume of output per year. So let's move over to Dimensions and try and create something similar to this. So first of all, we need to put the filter on. So we're going to move to down here, bottom left, put gold, limit to gold open access. We'll then move to publishers and timeline. So then we can see what's happening over time. I'm going to get rid of IOPP, no offense to IOPP, and just show that you can add publishers. So let's add Wiley. Okay, we'll then change from 2000 to 2024. And then we get the graph. So we can see here's MDPI. So remember, this is fully open access journals only. It doesn't include hybrid open access. It's quite useful if you hover over one of these individual data points, you can see what it is. That can be quite helpful. If you wanted to, you could click show publications and that would take you through to that. Again, go to the table, copy paste, put it into Excel, and that is the data for all the different publishers, or sorry, those 5 publishers. And then I would also need to go up to the overview timeline, change it to a table, move this back down to 2000. This is 2024. And then copy and paste this into Excel. So this is the total number of articles of all publishers. And then I can subtract the 5 publishers from these totals for the remaining publishers, if you like, that were included in that previous graph. So again, pretty easy to do. This is, it's not particularly complicated. And this is one of the real benefits of Dimensions, is it allows you to be able to quickly experiment and play around with the data very easily and very quickly. To get this graph, we need to apply 2 filters. We need to apply both the gold and the hybrid open access filter. And we've also got 5 publishers there. So let's try and redo this. So we can go to open access, gold, hybrid, limit 2, because we want the combined numbers. And then we can change this back to the timelines we want. So 2020, 2000 to 2024. So this is for the total. And then if we want a sense of which publishers have appeared there, so this is the total for all timelines. We can go back to the timeline here. And we've got, as we had before, those same publishers. We can go to 2000 to 2024. And here we go. So we can see here MDPI going up and then going down again. We can see Elsevier in 2024 being the top gold plus hybrid publisher in terms of article volume. And yeah, I mean, it depends how you want to do it. You can either copy and paste this graph, so you can just do a screen grab. So for example, I could do something like this and just copy that particular picture, and then get a copy of that onto my desktop. Or you can take the data, download it, put it into an Excel file. Okay, so this table is more complicated to produce in using data from Dimensions. I will try and talk you through it. Let's just stop and have a look at what we've got here. So we've got the ANZ SRC categories. So this is just the major ones for over 10 different years. And then the delta and the CAGR for each of these categories. So let's move over to Dimensions and we can have a look. We've got the same research article categorization scheme that we had before. And now we're going to go up to research categories. And you can see it's already on Fields of Research ANZ SRC 2020. These are all the different classification schema that Dimensions has. I won't go through them all here, but there are some other useful ones, particularly if you work in the health sciences. So what we have here is a long list. We can keep going down. It's loading up down here. Lots and lots and lots of data for the different categories. And you can see for the first time, we've got a button here, export table. So this gives us all years if we wanted to do that for the different categories. You can see some categories like biomedical sciences has only got 2 codes. So this is 32 or 2 digits. Whereas clinical sciences is a subcategory and it's 3202. So by hitting the export table, we would get all of the data at once. Now, unfortunately, we can't use what we did before, which was the timeline. This won't work because there's a limit. I think it's maybe 7 or 8 different categories that you can add to a timeline. So you can't get all of the data out across all the years. So what I did, and I'm somewhat embarrassed to say it just because it takes a while, is to then limit it by year. So you have to basically download the data 1 year at a time. So here I can limit it to 2024. So we've got the same category. I can then hit export table, and then I've got all the data for all of the, whatever it is, nearly 200 categories in the ANZ SRC categorization scheme for 2024 downloaded into Excel. And then, unfortunately, I've got to go back and go to 2023, limit to that, and then export the table again. So you do that 10 times, one for each year, and then merge the data in Excel using VLOOKUP, which if you don't know very much about Excel, VLOOKUP is one of the most useful functions in there. It allows you to merge different data sets together, and you end up with something that's helpful in terms of very similar to what we saw here with the table showing the number of research articles by year per research category. So that's how we did that one. So that's all I have for you today. I hope you found it to be helpful. I'm always interested in feedback, so please send me an email, james@journalology.com. If you have any suggestions, if you enjoyed it, let me know. It's always useful to hear from you. So thank you, and I'll see you again soon.